So here's our try. X cubed plus 3x squared minus 70x equals 0. Don't be afraid to look back at your notes. We're going to factor completely. Factor completely. If you want to give this one a try, which I hope you do, go ahead and press pause right now. And then when you press play, I'm going to give you an explanation that you'll want to hear. Okay, when I look at this problem, I see right away that we are already in standard form. So standard form, check. Standard form, check. And then the next step is to factor. Well, we have to always check for our greatest common factor. And in this case, each term has an x. So I'm going to factor the x out first and see what's left over. So I'm partially factored. This is a GCF factor. Now I need to factor a little bit more. So now I need to factor the trinomial. So I still have that x on the outside, but I'm going to have two binomials that are going to give me the x squared plus 3x minus 70. The way to get back to x squared is x times x, and then 70, hopefully you're getting better at this, 1 and 70, 2 and 35, 5 and 14, 7 and 10. And that's the winner. Winner, winner, chicken dinner. 7 and 10. I need a positive 10 and a negative 7. This is why it's so important to be able to factor. We spent so much time on that using whiteboards, because factoring is what we got to do from here on out in algebra. It just, algebra 2, it's filled with factoring, all sorts of fun factoring. So now I need 3 colored highlighters. The first variable factor is x. The second variable factor is x plus 10. And the third variable factor is x minus 7. I was just solving a problem like this in geometry video that I just made for what we're working on there. There are these examples, these equations in geometry that you're going to pull from your skills from Algebra 1. So I'm so glad that you're watching this video and trying along with me. X equals 0. That's our first one. I'm going to keep it highlighted because that looks a little weird. X could equal 0. The next one, x plus 10 could equal 0. And then the last one, x minus 7 could equal 0. So x plus 10 could equal 0, and x minus 7 could equal 0. So we've got one answer, 0. The other answer is negative 10, and the last answer is 7. So I've got 3 answers, 0, negative 10, and 7. And I really don't mind which order you write it in. It is absolutely fine to have 0, negative 10, and 7, or you can have it in any order you want as long as all 3 answers are there. Now, think about that. I said all 3 answers are there. Look at this. This is a degree 3. This is a cubic equation. A degree 3 gave us 3 answers. A degree 3 gave us 3 answers. If I come back here, this degree 2 gave us 2 answers. It just happened to be the same thing. But here's one answer. Here's the second answer, right? Degree 2, 2 answers. Come back here. Well, this was a degree 2. Degree 2, how many answers do we have? 2 answers. I think we're on to something. Degree 2, in our very first example, no, actually that wasn't our very first example, so we're going to be able to really make a deduction here that I think is going to be true. A degree 2, 2 answers. And there it is. This was a degree 2 as well, because if I would have multiplied that out, I would have gotten 2x squared, right? So that was a degree 2 as well. Degree 2, 2 answers. 2 answers. So When you have a degree 2, you should expect 2 answers. Sometimes it's a duplicate, but it's 2 answers. When you have a degree 3, you're going to get 3 answers. And if you have a degree 1, that's a linear equation. Those are our equations that we learned how to solve in 8th grade or 7th grade, maybe even 6th grade. Those only had 1 answer. Degree 1, 1 answer. Degree 2, 2 answers. And a degree 3, 3 answers. That is the fundamental theorem of algebra. The fundamental theorem of algebra is what you end up learning if you take college algebra. But you just learned it now. So look at that. Look at you doing it. Very proud of you. Now we got some practice to go. So, you know, the biggest hurdle is factoring. So I encourage you not to give up. Keep doing it because you're doing it.